All right, welcome to today's webcast, how Corelight and Amazon VPC traffic mirroring can bring network security monitoring to your cloud. Just a quick agenda here and a bit of housekeeping. I'll start by introducing today's esteemed panelists. Anoop Dewani will go over the VPC traffic mirroring functionality and use cases. Brian Dye, Chief Product Officer at Corelight, will be presenting on Corelight functionality. And then I will be walking through some sample use cases oriented around incident response and threat hunting using Corelight's data that's been VPC traffic transformed for security analysts. And lastly, we'll end on Q&A. And for Q&A, you're able to submit questions using the control panel, your GoToWebinar control panel. We'll see them. If it makes sense to answer in the moment, we will. Otherwise, we're going to save questions and answers for the end. We'll leave a few minutes at the end to do that. And if we're not able to get to your question, we will see your name and we'll be able to follow up with you afterwards. And lastly, recording of this broadcast will be made available and be posted on YouTube as well, so you can share it with colleagues who weren't able to attend if you'd like. So today's panelists. We're joined today by Anoop Dewani, the product lead for EC2 networking for AWS. Anoop's a product management leader in Amazon Virtual Private Cloud team and responsible for various EC2 networking products, and it has a diversity of experience in service provider, data center, and cloud technologies, and holds multiple patents in the areas of networking and virtualization. Brian Dye, our Chief Product Officer here at Corelight, is a veteran of the security industry, and he has a breadth of leadership experience across domains like infrastructure, security, InfoSec, cloud security, and security management. Prior to Corelight, he came to us from McAfee, where he was the Executive Vice President of the Corporate Products Group, and prior to that, spent over a decade at Symantec, culminating as SVP of Information Security Group there. And lastly, myself, I'm the Director of Product Marketing here at Corelight. I've worked in the data protection space my whole career in a variety of security, identity verification, and privacy technologies, and I'll be moderating today's webcast as well as presenting the use cases at the end as well. With that, Anoop, I'm going to give you screen sharing control, so you're able to control your slides here. One moment. Anoop, you should have the floor and screen control.
Thanks, John. Hi, everyone. Welcome to this webinar. My name is Anoop Dewani. We just launched a new feature a couple of weeks ago at AWS Reinforce called VPC traffic mirroring. This is a feature that allows our customers to monitor their traffic, VPC traffic, using any monitoring tool of their choice for use case like threat detection, content inspection, and so on and so forth. So over the next few minutes, I would love to get you a deeper insight into this feature, what capabilities this feature brings, and what you can do with traffic mirroring, and specifically with how Corelight integrates with Amazon VPC traffic mirroring, and how you can unlock a lot of use cases that were not previously possible. Having said that, John, I might not have the control. Can you?
Yep, 1 second. There we go.
Okay, thank you, John. Thank you. So VPC traffic mirroring is very similar to a fiber tap, or how a ray of light travels between two medium. When an incident ray travels between two medium, a part of the light gets refracted, a part of the light gets reflected. Amazon VPC traffic mirroring works very similar to that. You have packets flowing over the network interface, and you decide what kind of packets you want to copy and send it another direction, right? So at its core, let's take a look at what VPC traffic mirroring does. So let's say that you have an EC2 instance in your VPC, and you have traffic coming in and out of your internet gateway. You have green traffic coming in and the gray traffic going out, and you decide to monitor this traffic. What you do is you create, it's very simple, you create a traffic mirroring session, and before you create a traffic mirroring session, you deploy a monitoring instance, where you want your traffic to be delivered for analysis purposes. So with traffic mirroring session, when you create that, what you're really doing is you're enabling traffic mirroring on the ENI of an EC2 source. Once that traffic mirroring on that ENI of that EC2 instance is created, you can decide what kind of traffic you want to mirror to the monitoring instance. And in this case, we are mirroring all the traffic coming in and out of the VPC or on that EC2 instance, and that can be sent to a monitoring instance for further analysis. What kind of monitoring instance you can use? You can use your own analyzer. You can build your own. You can use some open source tools, or you can use our AWS partners or APN partners like Corelight. So why did we build traffic mirroring? Our customers have been asking for this feature for quite some time, and what they want is an easy way to detect network anomalies or security anomalies. They want to keep an eye out on that unusual traffic pattern so that they can figure out if they have been they are under attack, or they want to look at the content of the traffic so that they can figure out if a workload is compromised in their infrastructure. The second use case is for customers who want to do live troubleshooting and diagnostic of their application. As a lot of microservices talk to each other in their infrastructure, they want to see how traffic is traveling between those applications, between those microservices, so that they can figure out those vulnerable or blind spots or choke points between the applications. So our customers have been doing traffic mirroring using third-party agents so far. So what benefits does the VPC traffic mirroring give? There are several benefits. One is VPC traffic mirroring is a native AWS feature, which means you don't have to install unmanaged third-party agents. The second very important benefit is that VPC traffic mirroring improves your security posture. When you have an agent running in user space and you're trying to copy packets from the user space, there's a lot of things that you can do to the mirror traffic. And a lot of our security conscious customers do not want to copy packet from user space, specifically if they feel that the workload itself is compromised. With traffic mirroring, what we do is we mirror the packet right off of the network interface. And once this feature is enabled, you cannot disable or tamper the packets from user space. So you can be rest assured that what you're monitoring is the exact copy of the packets that are coming in and out of your EC2 instance. And lastly, our customers have expressed interest to have multiple monitoring tools to analyze different kind of traffic. So VPC traffic mirroring makes that possible. Since you are not running any agent, you're not logged in to a specific tool, you can actually send a subset of traffic to one tool and other subset of the traffic to another tool for your monitoring purposes. Now, a very high-level overview of what VPC traffic mirroring is and how do you create a VPC traffic mirroring. So there are three components here for traffic mirroring: targets, filters, and sessions. Let's take a quick look at all of these components. Let's start with targets. When you create VPC traffic mirroring, the first thing you need to do is you need to create a VPC mirror target, which is your monitoring instance. Today, there are two types of target that are possible with this feature. One is the ENI or network interface of the standalone monitoring instance running on EC2, or you can have network load balancer as a target, and you can have your appliances deployed behind that network load balancer in an auto scaling group. This is an option we recommend, by the way, if you have a large amount of traffic, or if you don't know how much of traffic you will be mirroring, it's better to point your mirror traffic to a network load balancer so that your appliances can scale up and down without you having to worry about overloading a particular target and sending traffic more than what it's capable of. A few things: you can have multiple sources sending traffic to mirror target. Again, if you have an elastic network interface as a target, it's very important that you do not send more traffic than what your EC2 instance or of target is capable of. Again, you should be using network load balancers so that you don't have to worry about scalability and high availability. Very important factor, we mirror the mirror traffic is VXLAN encapsulated. So on the target, you need to enable your security group to allow traffic on UDP port 4789, which is the UDP VXLAN, which signifies a VXLAN packet, a UDP packet with VXLAN encapsulated header. So that was target. Filters are very handy when it comes to mirroring your traffic. You can extract the traffic of your choice, so you don't have to mirror any traffic. So it's very mirror all your traffic. So it's very similar to a network ACL, except that there are two more options: flow direction and the packet truncation options. So what we'll do is let's do a quick exercise of creating a filter which allows you to mirror all inbound traffic, which is HTTP on port 80. So I start by saying I need to mirror all ingress traffic on a particular EC2 instance. I select the protocol TCP as HTTP traffic is TCP. The source could be anything, so the traffic can come from anywhere on any source port. The destination is the EC2 instance or the where I want to mirror the traffic. So destination should be the IP address of the EC2 instance or the source, and the destination port would be 80. Very similar to how you create a network ACL. And then you can choose to truncate your packet. You could choose to have first 200 bytes or first 1000 bytes of the packet delivered to instance and don't have to mirror entire packet. In this case, I say truncation no. By that, what I mean is I want to mirror entire packet and send it to my monitoring instance. So that was traffic filters. Finally, sessions. Session is an entity that binds your source with target and the filter. So it has three components: source, target, and filter. And this creates a relationship between source and target, and you mirror only traffic that is matched in the filter that you have created. You can have multiple sessions per source. This is where if you want to mirror a subset of traffic and send it to a particular tool, and the other type of traffic you want to send it to another tool, you can create sessions and the session IDs. I think, John, you took could you hand this back to me?
Sorry about that.
Sorry.
You should have control now.
Yeah, so you could have, sorry about that. So you could have up to 3 sessions, and the session numbers are essentially the priority of the session. So the lower session number means higher priority. So you could create a nested session such that session 1 can actually capture the traffic and send it to one monitoring instance, and the rest of the session can capture other traffic and send it to another monitoring instance. So to be specific, let's say that you want to mirror all your HTTP traffic and send it to a HTTP analyzer, and then mirror any traffic but HTTP traffic and send it to another tool. You could create a session number 1, only capture HTTP traffic, send it to your HTTP analyzer. A session number 2 can catch all other traffic and can send the mirror traffic to another instance. This is just a lot of these details are in our user documentation. We have our webinar coming up on AWS webinar coming up on 23rd of this month. So you can learn a lot more about the capabilities of traffic mirroring feature. One last thing is the traffic mirroring packet format. As I mentioned, that mirror traffic is encapsulated with VXLAN header. So here is the overall packet format. Your outer IP header will have a source IP of the mirror source. Destination IP will be for the mirror target. The UDP destination port will be the VXLAN port, and you have capability to set VXLAN ID when you create a session. So you have up to 16 million options here, and our users are doing a lot of cool stuff like creating unique VXLAN ID when they create the session. So when they have a lot of sessions terminating on a target, they can identify where this traffic was coming from by looking at the VXLAN ID of the packet. Again, there are a lot more details that you can learn from our user documentation or from the webinar that's coming up. And a last thing is that since we are encapsulating the packet with VXLAN to accommodate that header, we would truncate a packet anything over 8,946 bytes. So to meet the MTU budget, so either you set your MTU at your source around this number, or you should expect a packet that will be truncated at this byte. With that, let me hand it over to Brian to walk through Corelight capabilities.
Appreciate it, Anup. And for everybody, let me bring you back to actually where Anup started, right? Which is, if you think about the driving force that he was hearing from his customers, it's the same thing that I and we at Corelight hear from defenders all the time, which is, the reason that you want to get this access to that source traffic is for visibility and detection of network and security problems, right? In our particular case, we tend to find folks use us first for the security side of that, and then often use the same data kind of as organizations mature for the network side anomalies, but it really does start at the security piece. And the reason that this particular transformation of the raw network traffic has gotten so much traction is that over the last 20 years, right, because this was really open source based technology, right, we're built on the artist formerly known as Bro, right? The project was recently renamed Zeek, but you may have heard of it as Bro. The data has been curated over the last 20 years to be really optimized for exactly what defenders need. And it turns out that that's true both from a human perspective, enabling radically faster instant response, but also it's incredibly friendly from a machine analysis standpoint. So if you're using Python scikit-learn or any of the other kind of fancy machine learning toolkits, or even some of the great analytics frameworks that are available in many of the SIMs today, both the human analysis and the machine-based analysis, this data format is incredibly useful for that. And that's one of the really nice things about the traffic mirrors is that we're enabling all the downstream analytics that we've enjoyed in the on-premise world to extend into the AWS world as well. Now, if you look at the Corelight side of this, because I've been hearing the exact same thing that Anup mentioned earlier, right? If I think about the defenders that we work with, a very, very common roadmap request was, I love this data, it's feeding into my SOC, how do I get the same visibility into my cloud environments as well? The reason that we're getting that request is that what Corelight essentially does is we take that VPC traffic mirror feed and we translate that into very, very well curated security insight. And that tends to come in three forms. The first, which I'll talk about more in a second, is logs. We're doing per protocol, very, very deep insight logs. You can think of us as the Goldilocks between the relatively shallow NetFlow format, which is great for network performance management, not so great for security, and the overwhelming volume of PCAP, which is obviously great because you get everything, but you can't afford to store it for very long, and it's very hard to sift through at any real detail. So that's number one, right? This well-structured, highly dense, highly valuable kind of log format. The second is folks tend to use us to actually extract the files from the flow as well. This is particularly challenging with open source Zeek, but it's actually very easy and very high performance with Corelight. Folks tend to use that so that they can do subsequent analysis either in a malware sandbox or some other kind of related tooling. And the third is, and this is true for Zeek as well as Corelight, the underlying data is where a lot of folks start with Corelight, but where they build to is around either customizing that data or doing behavioral threat detection, so you're actually finding novel attack techniques on the network. And there's a bunch of community packages, community source packages that we'll talk about there, as well as customers have the ability to build that themselves, which in many cases folks actually do. So I want to do a bit of a double click on each of these three, starting with the logs themselves, because this is what is so fascinating, I think, about what's happening in the world of security right now, is that folks are starting to apply advanced analytics tool sets and machine learning and data science to security data. And when they start down that path, many folks realize that a lot of the data that's in their SIM or in their data lake was never meant for analytics, right? It's an operating log that was meant to be either a detection event or an operating notice from some other tool. And what makes Zeek and Corelight unique is that this is data generated for the sake of analysis. So it's a non-judgmental view of what's happening across your network. And what makes it so powerful, both for humans and for machines, is that it's all connected. So you might see a flow record that connects to a DNS log, that connects to a file that's being downloaded. All those are actually uniquely identified and connected across those various log types. So whether it's a human that's pivoting across different protocol types, or whether it's a machine learning algorithm that's doing the same thing, it's actually radically easier to do this. And if you go back into a very common kind of data science saying, it's a garbage in, garbage out. If you don't have good data, then the analytics you're trying to do can be tremendously painful. And the reverse is also true. If you have elegant, well-structured and interlinked data, everything else downstream becomes radically easier. And it's not just about connecting that data cleanly out of the box for Corelight, in an AWS environment, but it's also about connecting this data to all the other different security technologies that you might have. A recent development that, again, came from the open source world is this idea of a community ID. It's so simple. If we hash a 5-tuple the same way across, for example, Elastic, Corelight, Suricata, and Moloch, then you can take a signature detection that might have happened in Suricata, you can pivot that directly into the Zeek logs that you might be looking at in Elastic or Splunk, for example, seamlessly and deterministically. So you're not guessing based on timestamps or other events. You're able to directly connect the flow log from an alert into the Zeek logs, or even into a Moloch PCAP if you need it. So this concept of connectivity, whether it's across protocols or across tools, is really powerful. A lot of what we do here at Corelight is to make this data easy to get. So if you think about how simple this can be, and building on what Anoop was describing with the VPC traffic mirrors, the source traffic is coming from those EC2 instances. I would completely agree with his recommendation that folks should really be aiming that towards a network load balancer. So that way you can have pools of Corelight sensors behind your NLBs. And then those Corelight sensors are outputting the data into your SIM or data lake of choice. And then that's all being managed from our management console, which is called Fleet Manager, to do things like your role-based access control and your policy-based deployments and things like that. So it's a pretty simple flow, starting with the traffic mirrors to the NLB, to the Corelight sensors, and then ultimately getting the data where you want it, which is in your SIM or data lakes. Your defenders, your incident responders can actually work with it. If you look at that in a little bit more detail about how flexible and what kind of customization you can do here, there's a lot of options. We have done a tremendous amount of work to make the out-of-the-box experience into these various SIMs very easy to do, and I'll show you a bit more about Splunk, for example, in a minute. We also extract files. You can drop those into FireEye or Cuckoo or other kind of tool sets as you see fit. A lot of folks do like to do intel matching at the network edge, so we'll take ET Pro or MISP feeds and actually do that alerting there directly. And for the more advanced defenders, in many cases, they will want to personalize the data that's in their environment by, for example, bringing in information from a CMDB or whitelist or things like that. So a lot of folks will start out of the box with the logs and the extracted files exactly as they are, drop those into Splunk or Kafka or Elastic, for example, any one of the various partners we work with, and then build towards that customization over time. As an example of what that looks like, within the management console, we give a lot of visibility to what the actual network traffic looks like. So you can get the health of your environment, you can get the health of the Corelight sensors. One of the key things with network security monitoring, for example, is packet loss, right? Are you actually getting all the visibility that was originally intended with those VPC traffic mirrors? That can be pretty tricky in the open source world. It's something that we make very transparent with the Corelight commercial offering. We talked about log export, for example. Again, a really out-of-the-box experience. You can see a bunch of the options on the screen here. Splunk, Kafka, Syslog, Elastic. We find that a lot of folks actually use the JSON over TCP because that can support a wide variety of formats. And if you went into Splunk, you can again see this is a very simple kind of process. Enter the information about your deployment server. I'll talk more about filtering here in a minute as well, because that filtering tends to be very, very, very important. Files, likewise, very simple to export those files into S3 as a very flexible bucket to do other things with in your environment. We offer the same kind of export filtering capability for files as well, because if you think about the whole idea, starting with the VPC traffic mirrors flowing through Corelight, It's to get the data you want into the repository you need as easily as possible, because we want to let everybody keep their focus on the consumption of the data, the incident response, the analytics, the tool sets that you're bringing to bear, as opposed to the administration of the data pumps, if you will. And to that point, one of the things that we spent a lot of engineering effort on is controlling how much data goes to those different targets, right? Anoop talked about the filtering that's available within the traffic mirrors themselves, which is awesome. From there, you can also do additional input filtering into Corelight. We do a tremendous amount of export filtering, so you can do multiple streams of data into different places. So if you want to have your most rich security data into Splunk and you want to have a 100% copy of everything going into an S3 bucket, you can obviously do that. And a lot of filtering capability on individual log types as well as individual log items into each of those individual export targets. And we've also done a bunch of work even on data reduction. So really going through and pruning out and making sure that that Goldilocks kind of position, right, in between NetFlow and PCAP is as cost effective as we humanly can, especially candidly for downstream targets that make you pay by the ingest volume, for example, Splunk. We find a lot of defenders really appreciate that because, let's be candid, saving money never goes out of style. Now, once you're done with the stock logs, we talked about the insights, right? And there's a lot that we provide out of the box that have a range of capabilities. This could be operational aspects like finding expiring SSL certificates. It could be illegitimate use of resources like Bitcoin mining. I hope you don't have it happening on your network, but I fear that many of us do. And it could be things that are a combination of the two, right? J3, if folks haven't heard about it, is some really great work from the Salesforce.com engineering team that fingerprints the SSL client and server SSL handshake, so you can identify both benign and malicious toolkits that are happening in your environment, right? Being able to find Metasploit, for example, when it's being actively used, if that's not your red team, that's probably an issue. Another great example of insights that recently came out of the good folks at MITRE is a set of packages that are designed to look at the SMB and DCE protocols to find lateral movement amongst a number of other kind of threat vectors. And one of the things that we at Corelight are very focused on is continuing to foster and grow the open source community around Zeek, in particular with things like contributing their threat expertise and some of their behavioral threat detection capabilities to the broader community. And then we obviously want to package and provide those to commercial customers as well. So there's, I think, a lot that the community's already done. There's about 100 different contributed packages up on the Zeek Package Manager today, and we expect that to continue over time. We're obviously very focused on the cloud here, but most organizations run in a hybrid world where you have physical physical, remote, and in some cases even multi-cloud worlds. So if that's the world you're in, and it probably is, we're obviously here to support that, whether it's with cloud sensors, virtual sensors for remote offices, a range of physical sensors, and all those kind of get centrally managed by our Fleet Manager offering. With that, though, what I really want to do is to hand the panel over to John here, because I think the traffic mirrors are super interesting. I think Corelight's super interesting, but all of those are really intended to work together to serve the needs of the defender, which really comes down to how do you consume this data for better threat hunting, for better automation. So, John, let me hand over to you.
Thanks, Brian. So we're going to go through 4 use cases here. An automated data capture use case that Anoop's actually going to present architecturally, showing how that would work. And then I'll present 3 use cases built around IR and threat hunting workflows, as Brian mentioned. So we'll take a look at how we could use this data, this transformed VPC traffic transformed into logs and extracted files, how we could use it for threat hunting against encrypted traffic, how we can look for threats in DNS traffic as well, and also how it can accelerate incident response workflows. So Anoop, I'm going to give you back screen sharing control. One moment. You should have control now, Anoop.
Thanks, John. Doesn't look like though. Or you can click through.
Anything worth doing is worth doing twice.
There we go.
Yeah, okay. Thank you, I have it. Thank you, John. So traffic mirroring actually opens up a lot of new opportunities for our customers. Just in a short span of time, our customers have been using traffic mirroring to continuously monitor their sensitive workloads, A lot of times, what you see in your organization is that you have an acquisition or you have a new infrastructure merging in your environment, and you want to actually get a quick visibility of what those workloads are, talking or getting the traffic in your infrastructure, and what really is coming in and out of those workloads as opposed to what's being told to you as a security team. And also, traffic mirroring is being used for on-demand incident response, right? You figure out that there is an issue, there is some alert generated somewhere where there is a bad traffic detected. You can actually now automatically trigger traffic mirroring for incident response and look at what exactly that traffic is, malicious traffic is, right? The key thing here is automation. So a lot of our customers are doing a lot of cool things here. We have covered some of these scenarios in our breakout sessions at Reinforce, at New York summits and various other summits that we will be covering. One example that I want to give where you have, when you are actually using traffic mirroring at scale, there are very cool things you could do. One is, let's say that you want to monitor traffic where on your EC2 instance, where you have green traffic coming in, everything is good, but with that green traffic, there's some red traffic or orange traffic here on the screen that is bad traffic, right? So what happens is if you're using guard duty generates the alert, guard duty sends the alert to CloudWatch, and as of now, this is where actually you stop. But with traffic mirroring, what you can do is, as the CloudWatch alert comes in, you can invoke a Lambda event. That Lambda event can figure out where this traffic is, where this alert was generated, what ENI that, for instance, that Lambda event has to monitor. It can automatically launch a Corelight AMI so that you can monitor the traffic. Then that Lambda event can initiate traffic mirroring on the source or where the problem is. And once that's done, you can actually now get the real copy of the packet, which you can actually, further analyze to see what exactly is happening in your network. And once that happens, you could actually ship the logs to S3 bucket, and from there, you can use Amazon Athena to look at the logs and have humans take the high judgment call. So the bottom line here is that you could actually have these automation in place for incident response. There are a lot more possibilities, but this is where we see how customers are trying to use traffic mirroring. A lot of this framework we will shortly post it on GitHub so that you could actually just use this kind of workflow. But with the automation, I think you could actually scale and have all your instance either continuously monitored or you could use it for incident response. John, I'll hand it back to you now.
Thank you, Anup. I'm going to let Brian jump in here real quick.
Yeah, I just wanted to give a big +1 to Anup's example, because one of the things that we've really enjoyed doing over the years, because at Corelight we support both the commercial offering but also work with the open source community quite a bit, is that the retail side of Amazon is a big and very public user and supporter of the open source technology Zeek. So this walkthrough that Anup is going through is not just theoretical. This is kind of from the minds of the same folks that have used Zeek extensively to help defend Amazon and all of us that are purchasing on Amazon on a day-to-day basis, which I'm pretty sure statistically is all of us on this webcast. So we all have aligned incentives on this one. But it's a really cool use case and great to see kind of the use of the technology for exactly these types of incident response and threat hunting kind of use cases that we talked about. So it's a great example. So
it's a great point, Brian.
Yeah.
So I'm going to go through some sample use cases here with the data. The first one we'll be looking at is how we can kind of look at the encrypted traffic that Zeek and Corelight parses from these VPC streams and what we can actually tell from an insight perspective to zero in on suspicious activity or potential malicious activity. I'll be showing these demonstrations here in Splunk, these screenshots, but again, this data can go in whatever SIM or data lake tool you prefer, whether that's Amazon Athena or Splunk or Elastic or your own homegrown data lake. we're highly flexible in the ability to export. So we're just picking Splunk here since that's a popular SIEM that a lot of people are familiar with the UI for. So let's talk about kind of the threat before I dive into the use case here. Network traffic, corporate traffic is increasingly encrypted. So are attacks. Attackers have wisened up to kind of the defensibility of encrypting their streams to evade, certain signature or behavioral-based products that might try to inspect that traffic and trigger against it. Encrypted traffics are on the rise, and this particular statistic here came from A10 Networks, shows that almost 50%, approaching 50% of cyber attacks that they measured were actually using encryption, using SSL to try to evade those types of defenses. So what can Corelight and Zeek parse and give you insight around this traffic without breaking and inspecting it? Well, there's a couple key functionalities that Corelight brings to bear against encrypted traffic. Identification. So Zeek, the underlying engine that Corelight is using, is excellent at identifying traffic, which on its face sounds like a simple problem, but it actually can be quite challenging. A lot of tools out there are relying on simply header information for traffic to correctly self-identify, which we know can be unreliable. So Zeek actually, Corelight use of Zeek actually throws its protocol parsers against every stream it sees until all but one fails. So it's exceptionally good at detecting traffic on off-port protocols or just strange behaviors where you're seeing traffic that shouldn't be in certain areas. It's extremely good at identifying that traffic. So Corelight can identify encrypted traffic wherever it occurs, even if it's not over expected ports. Parsing. So the traffic itself is encrypted. We're not breaking and inspecting it, but there is still a ton of security insight that can be gleaned by looking at the nature of the encrypted handshake itself before it becomes encrypted, and also the certificate details. So kind of certificate hygiene, certificate analysis, there's a ton of detail there that has great security value. Context is another key functionality here. So we can take those encrypted streams, those encrypted VPC streams, and connect the connection activity that is unencrypted but related to that encrypted stream. So if there's a DNS request, for example, in the clear that then becomes an encrypted connection, that connection ID that Brian mentioned, that connects those two different protocol activities together in a single stream connection, and you can actually pivot from that DNS request into the encrypted stream. So you're getting the broader picture, because typically with an attack, it's not just 100% encrypted. There is inevitably some component of that attack, whether it's in the earlier stages or even the later stages, where that's not going to be encrypted, and you need to know about those connections. And lastly, analysis. So Brian mentioned some of the Zeek packages that Corelight bakes into our sensors. There's a whole open source community on GitHub as well. I think it's north of 100 packages as well. But really the power of an open source technology like this is that you yourself can write custom analyses, and you can automate encrypted analyses using the Zeek scripting language as well to generate insights against encrypted traffic. And I'll give you some examples here. The logs you're seeing there on the left, I've highlighted. Those are just some of the encrypted streams that Zeek and Corelight can parse. So we see an SSL log there on the left, the X509 log in the top right there. So that's looking at the certificate details. An SSH log before that, below that. Corelight and Zeek also parse Kerberos, for example. So there's a number of different encrypted streams, encrypted protocols rather, that Zeek and Corelight are capable of parsing. So these will be the critical logs we would use in a sample use case here for this threat hunt. And first, we kind of need to form some hypotheses about what we're looking for, because if we don't have a strong hypothesis about what attackers are doing, we're not going to be able to zero in on potentially suspicious or malicious activity. So our assumptions here are that, one, attackers are going to be using SSL, which, as we saw in that first slide, is now a quite common behavior in attacks. And two, that the profile of that SSL traffic that the attackers are driving is going to be strange, anomalous, and probably of low encryption hygiene, if you will. So we're looking for things like the use of self-signed certificates, because they're probably not going to be using, in most cases, a known domain certificate authority to generate their certificates. They're probably self-signing them. We're looking for things like soon to expired or expired certificates. We're looking for lower grade TLS versions. And we're just keeping an eye out for anomalous or strange details in the certificates themselves that would be atypical of a legitimate certificate. So again, this is a screenshot from Splunk here, and we're keeping the lens, the aperture wide open right now. We're just trying to get a sense of what's all of the SSL traffic going over, coming from the VPC mirror. just show me kind of what's the state of affairs here. So what we're looking at here is we're seeing TLS versions being used. We're seeing the originating hosts that are originating those connections. We're seeing cipher details here on the rightmost column, and we're getting a sense of, okay, we're starting to see what the footprint of encrypted traffic is in our environment, and we're seeing things like, oh, okay, so a lot of people are using 1.2. You know, there is 1.3 available. We wouldn't expect it to be a majority of traffic right now, but that's kind of expected behavior right now. Let's take that aperture and let's close that a little bit and look more specifically at, I want to understand what the version and validation status of certificates and encrypted traffic being used in my environments are. So what we see here on the right is we've now sorted this query by count for version and validation status, and we can see things like SSL version 3, very old here. Certificate is, of course, obviously expired. There's 3 counts of that in my environment. We can see things like TLS 1.2. We've got 2 counts of self-signed certificate use using TLS 1.2. So now I've zoomed in a bit and I'm getting a more insight into the nature of what's happening in my environment. And now I can start to focus a little bit, because again, we're looking for self-signed certificates, we're looking for anomalies within those certificates, we're looking for downgraded TLS versions as well. So now we're zooming in and starting to see some of that behavior. Again, not a smoking gun, but we think we're on the right track now. So now we're actually looking at some of the certificate details themselves of these connections here. And these are self-signed connections here using TLS 1.0. And immediately, if we look in the issuer column here, we're seeing some strange things. We're seeing registration details that probably don't represent a legitimate certificate. It's registered to an Obama at us.com, a location of the Gaza Strip in Gaza City. So strange, could be benign, but probably someone didn't want to register themselves or a corporate entity around that certificate use. We're going to double click on that. Now, Brian mentioned the JA3 script earlier in this presentation. That's fingerprinting the TLS client server connection, right, with a unique alphanumeric hash. So you can actually blacklist, whitelist, and track these certificates. So if we pivot again into the actual SSL log built around that connection, we see that JA3 hash there in red highlighted that's hashed that connection. So we could take that JA3 hash and we could query it against a blacklist in the community or our own blacklist. And in this use case, let's imagine that comes back a hit. It's a known certificate being used in known malicious domain infrastructure by attackers for C2 use. We've got a smoking gun now. And so we went from kind of broad hypothesis about where we think attackers might live and where we can zoom in on suspicious activity to we actually potentially now have a smoking gun. And this kind of demonstrates what Zeek and Corelight is so excellent at, which is kind of tearing through all the encapsulation layers in network traffic, whether it's encrypted or not, and pulling out all the security relevant detail in the right format for security analysts and security machines to consume and derive insight from in as fast as possible here. So the third use case I want to talk about here is DNS tunneling. So we're going to be looking through some of the logs that might be generated out of the VPC-mirrored traffic. And we're looking for attackers hijacking of DNS traffic, which is quite a popular tactic and one that I think doesn't have as much recognition as it should from a defensibility perspective. There are many, many ways that attackers can manipulate your DNS traffic, from trying to hide in plain sight because there's so much volume, whether it's east-west or north-south DNS traffic, there's just so much DNS volume for them to hide it, number one. And number two, they can do things like encode C2 commands or calls inside of those DNS queries, or actually exfiltrate data via DNS queries by basically breaking up files into small parts and packaging those parts in separated DNS queries and then reassembling them on the other side. So there's a wide variety of abuse tactics that attackers use to hijack DNS, and it's quite a prevalent threat. And Zeek and Corelight are an excellent tool to parse this DNS traffic to give you visibility into where this might be happening. So the key logs here that we're looking at are going to be the connection log and the DNS log. So the connection log is that master kind of NetFlow on steroids record of the connection, and the DNS log here is the Zeek DNS log generated by a Corelight Cloud Sensor in this instance. And it's a much richer record of a DNS connection than you're typically going to get out of your DNS server. So it includes things like the full 5 tuple. It includes the actual DNS response, which is not something you're typically going to see in a DNS record unless I think DNS debugging mode is enabled. But again, that's if DNS server logging is enabled, which in many environments it isn't. For performance reasons, the IT team, networking team doesn't want to turn on DNS server logs. You have to get those server logs into your environment, your SIEM, your data lake of choice. These are all challenges that security analysts and security teams are well familiar with. Here, you have a single source of data for DNS and all of your other traffic records that you can pivot into. So again, back to this hypothesis, how are we going to take this overwhelming, potentially overwhelming amount of data and zero in on something that can give us some insight into our environment? So number one, we're going to assume that attackers are potentially abusing DNS traffic in our VPC environment. Number two, we're going to look for non-human characteristics of DNS behavior, because in many cases, DNS is a human going out and querying a domain, saying, I want to go to Amazon.com, I want to do some shopping, and what's the IP address for that? Can you connect me, right? That's a human behavior and does have certain human characteristics, whereas machine-driven DNS behavior, which can be completely legitimate in some cases, but otherwise can be used by attackers, typically has strange alphanumeric strings in the DNS requests, extra long DNS requests as well. So we're going to go into this exercise here with some assumptions, which is we're going to be looking at DNS queries that are longer than 25 characters in length. So I believe most DNS queries have a cap of about 255 characters. So we're casting quite a wide net, and yet most human-driven DNS queries are probably going to fall below that 25 character count. So we're going to be filtering out a lot of known human activity in this. And then we're looking for answers that exceed 45 characters, which could potentially represent a received C2 command from an attacker. And then we're also just looking again for anomalous or strange behavior within this ecosystem. Things like huge volume of queries, a very talky host who's making a ton of queries, that kind of behavior that we wouldn't expect. So here, we're basically, again, casting that net very wide. We're trying to get a wide sense of what the DNS activity is within our VPC environment. And below here, we've clicked on the connection ID, and we're actually seeing the DNS queries here for this particular originating host. And already in the query, we're seeing some potentially strange, potentially indicative of attack behavior. Very long encoded strings that don't really resolve necessarily to a visual inspection for clear subdomains. There's a lot of subdomain activity as well. They're ultimately resolving to this domain, sweetcoldwater.com. Let's double click, let's take a look here. So now we want to see what are the actual responses to those queries that are being generated here. And again, this is something you're not typically getting out of a DNS server record, so you're just blind to the answer if you're a security analyst relying on DNS server records. And if we look here on the left in the answer column, again, we're seeing these encoded strings of information being responded to, and we're starting to get a little bit more suspicious here. And we can actually pivot from these connections into the connection log. That's that NetFlow master record, if you will. And Brian mentioned the community ID earlier in this presentation. So one could imagine if you're also collecting PCAP as well to do raw packet analysis on, you could actually use the community ID from the con log that you've just pivoted into to go actually dig into those DNS packets that are being returned and being sent out across your VPC environment. And the analyst can get very, very precise packet level granular insight. You can effortlessly pivot into those packets with this Corelight Zeek connection log, because it's going to give you that ID that lets you pivot right into that same 5-tuple coming out of a tool like Moloch, for example. And you're going to be able to drill in, and let's imagine you drill in and you start to see very, very strange things like it's your data being exfiltrated in that query that was initiated. We can also sort here by that host that we were originally looking at and seeing who else did that host talk to. And we're immediately seeing this is a very, very talky host, potentially indicative of scanning behavior as well. And we can also look at the history and connection state here. So we're just basically, again, zooming back out a little bit here to get a sense of what is the behavior of this host. Last use case, accelerating IR workflow. So Zeek and Corelight, the data that this product generates, so it takes your raw VPC packets and it transforms it into this highly usable security data, and that can have dramatically beneficial consequences for security workflows. So this is just a snapshot of a quick case study we did with a large organization, Education First, global multinational, 40,000 employees. And they saw a dramatic reduction in their incident response time when they switched from using kind of typical flow logs like NetFlow and then started suddenly having all of this rich data that they can quick pivot through. They saw a 95% reduction in average incident response time. They went from multiple hours on average to minutes. Dramatic time saving. And as we all know, in security, speed matters. All right, so let's imagine here that an alert is fired and you need to go dig in as a security analyst into a potential, let's call it a phishing alert, right? And that phishing alert says that the domain associated with the phishing alert is mybusinessdoc.com. So we're gonna go into Splunk. In this example, this is our SIM. We're gonna say, show me all of the logs everything we know about this domain. Corelight, show me what you know. And so we're immediately getting logs in return. And our first log here is a DNS log. And if we look further down, we find an HTTP log here associated with this domain. And we start to see some strange activity here. We're seeing file activity associated with this HTTP session. So what you're seeing here is the file ID, that FCZ alphanumeric string. That is a unique file ID that Zeek and Corelight stamp every file with. So you can easily pivot across file activity on the network while sticking with the same file. But what we see here that's more interesting is the mismatch between the file name, which is a .gif or GIF, and the MIME type, which is an executable. So already there's a mismatch there. Something might be masquerading with the intent of causing harm to the end user. So let's take what we know about this file here, and let's go back into the data and take that file ID. That's the file ID right there. Plug it back into the system and say, Corelight, show me everything you know about this file and where else has it touched my VPC environment. And we can take that file ID and we now have a files log here. So we're looking at that log that gets generated for every file that crosses the network. And we can see here that there is a receiving host that got this file. And we also have the hash, the 256 SHA-256 hash. So Zeek and Corelight auto hash all the files crossing the networks as well. We could do a quick lookup on some tool like, I don't know, VirusTotal or any other file analysis tool and quickly discover that's actually a malicious file. So now as an analyst, I've gone from a security alert of unknown value, right? We're always worried about false positives in the security world. We've now verified that there's file activity associated with that domain. There's a mismatch in the file type, and the hash of the file is a known malicious file in the greater security community. So we've gone from potential problem to we're definitely dealing with a problem here. Now we want to understand the scope of this problem. So here's that file looked up on VirusTotal as an example. So now we want to go back in and we want to say, where else did this file cross the network? Again, using the SHA-256 hash. And who got that file? What other hosts in my environment were affected and downloaded this file? We can already see it was only one host, and we can see that it was the same IP as the original phishing alert that fired. We know the problem is contained to that single host that the security tool fired on. We know that that's the extent of where we need to contain this problem, in addition to putting other defenses on in our environment, and we can resolve this ticket and initiate containment and remediation. Now, I'm not a skilled security analyst. That took a few minutes. I think someone with greater skill set than mine could probably do that in a matter of 2 minutes, which is a dramatic time saving compared to basically foraging for logs and manually tearing through PCAP to try to come through to the same insight.
Well, and John, that brings up something I hear a lot from defenders, right? Which is if you think about the power of the data, right, and the richness of the data, again, connecting back to what Anoop was saying on the traffic mirror, generating that data through the Corelight sensors, and then actually getting access to that for the defenders in their console. One of the questions I hear a lot about is, look, there's a ton of data in here. I'm used to firewall logs, or I'm used to NetFlow, right? How do I get up to speed on consuming this? I think the good news is, as far as an answer is there, it seems like you've got a bunch of avenues to kind of get up to speed there. If you go to SANS and get trained on incident response, you're probably going to get trained using Zeek data. If you go to Cisco and you get trained on incident response, you're generally going to get trained using Zeek data, right? If you're using Security Onion, which a lot of folks do to kind of sharpen their own security skills, Zeek is one of the anchor tenants to generate that data into their analytics stack as well. So there's a lot of ways to get a lot deeper beyond what we've covered in the webcast today. I mean, don't get me wrong, you covered it in great depth, but there's a lot of ways where folks can get their hands on this or get formal training depending on what they want.
And as someone who came to this new a year and a half ago with no background, I can say that it looks intimidating at first. It's really not. These logs are so well structured and so intuitive that once you understand kind of what the nature of the logging framework is and what these fields mean, it becomes second nature.
Yeah, it comes in quick. So I know we only have a couple of minutes left, but I think it's a great time to take a look at the questions queue and kind of see if folks have anything that they want to cover. Let's pull that up real quick.
Yeah, we got a question here about licensing. Two questions, one about Amazon and us. We'll start with us. So the Corelight Cloud Sensor, how is it licensed?
Oh, we look at the capacity of network traffic flowing through. So it's the volume of logs on an ongoing basis, not an accumulative basis being generated. So pretty simple, actually. We want to make sure that that folks are able to be as flexible with the ramp up and ramp down of their capacity as they need to, and so that's why we picked that model. And
Anoop, we have a similar question. How is the Amazon TAP priced?
The VPC traffic
mirror, yeah.
Sure. Yeah. So the pricing for VPC traffic mirroring is very simple. We charge 1.5 cents per mirror source. Users are not charged based on how much bandwidth they're mirroring. So it's a simple hourly charge of 1.5 cents in US region, and I believe 1.8 cents per hour in EU and Asia Pacific region.
Great, thanks. We've got a few more minutes left, so let's go to some of these other questions here. How about this one? Do you think Corelight logs can replace NetFlow and/or PCAP? I'll take a quick stab, and maybe Brian, you want to elaborate?
Sure.
I think from a security use case, NetFlow, absolutely. Zeek logs can replace NetFlow. You're going to get a ton more value from the connection log alone that Zeek and Corelight generated, not to mention all the other protocols that it parses. So NetFlow, absolutely, from a security use case. PCAP, I would say it depends. We've seen some customers that have made a calculus, which is basically how much visibility do I want for how long? And there's a trade-off with PCAP where you can only store so many hours or days or weeks worth of PCAP, leaving you blind to network traffic activity beyond that window. And as we know, dwell time is measured in months. So yes, I've seen some customers basically say we're going to lean in on Zeek, and we believe that Zeek can replace a majority of our PCAP use cases. Other customers see them as complementary, which they are. You can actually enhance your PCAP investment by using Zeek as kind of the roadmap or the map sitting on top of PCAP that allows you to quickly pivot into those packets that you need very efficiently when you need it.
Yeah, I think you hit the key trade-off there, John, which is it's about coverage versus cost. If the advantage of Zeek over PCAP is that because it's 1% or less of the overall PCAP volume, and it's well structured, you can get access to it quickly. You can keep it for radically longer periods of time, right? Most folks that are using Zeek keep it for years, not days or weeks, right? So in terms of investigating material threats, the stuff we care about generally happened kind of months ago, not days ago. It's tremendously valuable there. But that calculus has to be trade off with there are some things that are not in the Zeek logs that are in the PCAP, right? If you're looking at fileless malware, you need to get access to the individual original network PCAP flow to see that, or of course, potentially you're getting that insight from your EDR tool, right? So if you think about some of those threat vectors, you either need to have another way to have them covered, like in the case of EDR, that might be a great answer, or just be aware of what you're trading off. But what we do find is that many folks, if they're not outright replacing PCAP, they are augmenting it because very, very rarely can you afford to keep PCAP more than 7 to 14 days. That's fine for very short-term IR. It's not good for threat hunting, and it's not good for your advanced adversaries.
Well said. And with that, I think we're at the hour. So I will call this a webcast. Unfortunately, we didn't get to answer some of the questions, but we'll follow up if we didn't get your question answered. Anoop, thank you so much for joining the Corelight team today to present on VPC traffic mirroring. And Brian, of course, you as well. Thank you.
Happy to, and I hope everybody here took away a couple of things, and if nothing else, I think if you haven't started playing with the traffic mirror, you obviously should. If you haven't started looking at how to use that traffic mirror content to create some pretty fantastic security insights, we're obviously happy to help with that on the Corelight side.
Yep, and we've got a bunch of YouTube videos on our Corelight channel as well if you're interested in more hands-on training type material. Anoop, sorry, did you want to put in one last word?
No. Thanks, John. Thanks, Brian, and thank you, audience here. We're excited to give you this functionality, and we are all ears. If you have any feedback, anything that you want us to implement more, we are actively watching forums, Twitter. You can reach out to us as well. So there's a lot more opportunities here, a lot more use cases that you can unlock with this feature, and obviously, with the Corelight use cases that were presented. So just keep us posted. If you need anything, if there's any feedback from Amazon perspective, we are all ears.
Great. Thank you, Anup. With that, we will call it a webcast and wrap it. Thanks everyone for joining. Have a great day.